So when we had this, what are we looking for? What values of x makes this true?
Or
Well,
it could be 0.
So now we solve for x. So we subtract 3. 2x is greater than -3. Anything x is greater than -3/2. Is it open or closed circle? So x is greater, so it goes this way. So my solution is -3/2 to infinity. So we have the interval method, the set notation, and the graph. We'll do the same thing here, except things change just a little bit. X squared minus 4x minus 5. Our graph changes now. What does this function look like? So let's solve it. It has to be equal to 0. Check. We factor it out. Opposite signs. What times what is 5 when you subtract and be at 4? 5 and 1. So my intercepts are at -1 and +5. Are they open or closed circles? They're open. So far, so good. Now, are my solutions going to be in this domain, or in that domain? So if because of this, it's either going to be between these two, or if it's not between these two, it's going to be on the other side. So pick a number, let's say 0. If we plug it in there, 0 squared minus 0 minus 5, is -5 greater than 0? No. So that's false. That means our solutions are from -infinity to -1, union 5 to infinity. That means all those other ones will work. Yeah, so we can have at most 2 solution sets. It's a quadratic equation. We can have 2 solution sets.
Also,
How many you can have? Because remember, we're looking for solutions. How many solutions can we have? Since we're looking now for ranges of numbers, no longer just individual numbers. If we graphed it, we look like this. Is the answer going to be inside here, or is it going to be inside on the outside? Since we know this is not true, it's anything else on the outside works. X squared plus 3x minus 5 less than equal to x plus 3. What do you got to do first? Set it equal to 0. Let's move over, subtract x and subtract 3 from both sides. So we have x squared plus 2x minus 8 is less than equal to 7. Factor it out. It's opposite signs. What times what is 4? When you subtract them, you get 2. 4 and 2. It's the stuff we've been doing all along, factoring. So my intercepts are at -4 and +2. Are they open or closed circles? They're now, it's either going to be on between them or the outsides. It can only be one or the other. It can't be all 3. So let's pick one. Can we pick 0? Yeah. So let's put 0 in there. 0 plus 0 minus 5. So minus 5, is it less than equal to 3? So that's my domain. That's my answer. It's between -4 and 2. Or -4 is less than equal to x is less than equal to 2. Any one of those answers, depending on how it wants to give it to you. Make sense? Because these are inequalities. It's more than one answer. Now it's a series of answers. Example 3. X cubed minus x greater than 0. So how many intervals we're going to have here? Well, let's see. We're going to have 3 solutions, 3 intercepts. How do we solve those? How will we solve the intercept? How will we find the x-intercepts? And what can we factor out? So we have x squared minus 1. Can we factor out x squared minus 1? What is it? The difference of 2 squares. X squared minus 1 squared makes it x plus 1, x minus 1. Very good. So my intercepts are at x equals 0, x equals -1, and x equals +1. Are they going to be open or closed circles? Open, since there's no equal sign. So now we look at these domains here. If we were to graph them, what would the graph look like? It's a cubic function. That means the end behavior is what? Opposite directions. Is it increasing or decreasing? So this side goes down. So it would look something like this. So what solutions are we looking for? We're looking for only parts of the answers that are above the x-axis, because it's greater than 0. So our solution is that. We only want part of the graph that's above the x-axis, positive. And the only part of the graph that's above the x-axis are those 2 intervals. And that occurs from there to there. Instead of plugging in numbers, you can look at the graph. We want only parts of the graph. What part of the graph is positive? Positive means above the x-axis. Okay, we'll leave it that. I mean, what we have left to do is the inequalities. I mean, the rationals, the fractions. That shouldn't take us more than about half an hour next time, and then we'll start chapter 5. And chapter 5, some sections are really short. It shouldn't take us that much time. So I'm thinking we should